Hi, I'm going to show you how to do an old exam problem. This problem came up during our past tutoring session. It was from exam 1 of spring 2009. It has to do with a mixture of butene and butane. They give you the mass of the mixture total, as well as the amount of CO2 that came off after burning. And it gives you two equations for the combustion of butene and butane. The issue with this problem is how to approach it, since they haven't really showed you how to do mixtures of things with their chemical equations. So I'm going to designate butene as A and butane as B. So to start, let's go with what they gave us. We know mass total. What we want to find out is the mass of A. So mass total is actually the mass of A plus the mass of B. The other thing we know is the amount of CO2 that came off, which was given as a mass. We can convert that to moles of CO2. Now X here I'm going to designate as meaning moles. So we have moles of CO2. So how do we relate moles of CO2 to our components butene and butane? Well, the CO2 came from moles of CO2 that came from A plus moles of CO2 that came from B. So how do we find the moles of CO2 that came from A? Well, we have our chemical equations here that give us a relation between butane and butene with CO2. So starting with butene, which is component A, we're going to say moles of CO2 equals moles of A times the relation, which is 4 moles of CO2 over 1 mole of A. So 4 moles of CO2 over 1 mole of A. And that equals the moles of A that came from butene. You can do the same thing with component B. Equals the moles of B times the conversion, which is 8 moles of CO2 per 2 moles of B. Moles of B. So now we can take these two things and plug them into our equation that shows us the total moles of CO2. So we have, let me pull this up here. X moles CO2 equals moles of A times the conversion, which is 4 over 1, plus moles of B times the conversion, which is 8 over 2. Now you say, well, we don't know the moles of A, we don't know the moles of B. Well, we know that moles of A equals the mass of A divided by molecular weight, which happens to be mass of A times 1 mole per 56 grams. And we can do the same thing for component B. Which is mass of B times 1 mole per 58 grams. So now we have a formula for moles of A and moles of B. Plug this back into the equation and we get moles of CO2 burned off total equals moles of A, which is mass of A times 1 mole over 56 grams, times the conversion here, which is 4 over 1, plus, I hope I'm not forgetting anything, plus the moles of B, which is mass of B times 1 mole over 58 grams, times the conversion here, which is 8 over 2. Now we have a new relation between moles and the mass of your components, which is your mixture. So to look back, we know how to find moles of CO2 because we have mass of CO2, and we can divide that by molecular weight to find the moles of CO2. Now, this is what we're looking for. Moles of component A, or mass of component A, which is butene. We have this equation, which is equation number 2, and this first equation, which is the total mass. We have here mass of A plus mass of B equals the total mass, which is given. Now, since we are looking for an equation that has just mass of A, we can say mass of B equals mass total minus mass of A. So we're going to take this equation and plug it into number 2 down here. So we have mass of CO2 times 1 over the molecular weight, which is 1 mole, 44 grams CO2. Okay, so that's moles of CO2 times mass of A, and then 1 over molecular weight times the conversion, plus mass of B, which we have an equation for, which is mass total minus mass of A. So mass total minus mass of A. Plug that in here. So we have 1 times 1 mole over 58 grams, and the conversion. So now we have a known, then our unknown, and this is what we're looking for, and we know this, and we have another piece of our unknown. So all we need to do is plug in our numbers and then get mass of A on one side of the equation, plug everything in, and it should equal 2.54 moles of A. Moles of butene in the mixture. Wait, no, that's mass. Sorry. Mass grams of A in the mixture. So the problem with this old exam problem is that where to start. The thing that they're testing you here is how to relate components and use what you know and find relations. They'll give you everything you need, so all you have to do is use your chemistry skills.